Hello students, here we are at Saxon, Algebra 2, Lesson 11b, Angles in Circles that Intercept Arcs, the proof. Text page 64, the four circles at the bottom of the page. These four circles are there to step you through a kind of proof showing mathematically that the measure of an inscribed angle is only half the measure of the arc that it intercepts. Let's unpack that proof. The first circle diagram. Let's get oriented. The angle we are interested in is the inscribed angle ABC. Does angle ABC equal 1/2 of the measure of arc AC? Notice that O marks the center and therefore BC is a diameter. They have drawn a dotted line from the center to point A to make a triangle for the purpose of the proof. This is perfectly acceptable in proofs. Two dots define one line. The numbers 1, 2, and 3 refer to angles that have different measures. There are two angles marked 2 because they are congruent. That is, they are equal in measure. Angles 1 and 3 form a straight angle, which equals 180 degrees. Why are the two angles marked 2 congruent? Remember that O is the center of the circle. That means that OA, OB, and OC are radii of the circle, and all radii are congruent, that is, equal in length. OA equals OB equals OC. Therefore, triangle AOB is an isosceles triangle. AB is the base, and the two angles marked 2 are its base angles. The base angles of an isosceles triangle are always congruent. The angle marked 3 is the vertex angle of the isosceles triangle. If you need to think about this, don't be shy. Pause the video. Okay, on to the second diagram. The second diagram. In this diagram, they have included the measure of the arc. We need this measure because this proof will use numbers to show that the measure of inscribed angle ABC equals 1/2 of the measure of arc AC. Therefore, we expect that angle ABC equals 40 degrees. Note, rigorous proofs do not use numbers, but they are a little beyond our scope at this time. The third circle diagram. Since angle AOC is a central angle that intercepts arc AC, its measure is also 80 degrees. Since angle AOC and angle AOB form a straight angle, angle AOB must equal 180 degrees minus 80 degrees, which equals 100 degrees. You can see that they have marked angle AOB as 100 degrees. Remember that this angle is the vertex angle of an isosceles triangle. The last circle diagram. In this last diagram, they have marked the two base angles of the isosceles triangle AOB as 40 degrees each. Where did that measurement come from? We know that the measure of the interior angles of any triangle equals 180 degrees. The measure of the vertex angle equals 100 degrees, which leaves 80 degrees for the two base angles. And since the base angles are equal, each base angle equals 80 degrees divided by 2, or 40 degrees. That's the proof. Note that inscribed angle ABC equals 40 degrees, which is 1/2 the measure of the arc it intercepts, arc AC, which equals 80 degrees. We showed this by using numbers, geometry, and algebra. This is one kind of proof. What we proved: the measure of an inscribed angle is half the measure of the arc that it intercepts. QED, that's a Latin acronym for I proved it. I hope this video helped you to make sense out of the proof in Lesson 11B. See you next time.